All right, let's get started. Welcome, everyone. As a senior engineer, I've always believed that one of my absolute most important jobs isn't just writing code. It's making sure we have a rock-solid, totally professional system for how that code actually reaches our users. So today, in this Mentorship Explainer, we are officially standardizing our professional workflow. We're going to take a really close look at our branching strategies, our code review practices, and how we can ship with absolute confidence. Basically, we're moving away from ad hoc habits and laying down the engineering standards that truly separate amateur hour from world-class teams.
But hey, before we get into the weeds with the mechanics of Git and branching, I really want this specific number to sink in: $51,400. That is exactly what one single line of unreviewed code cost a company in just one 4-hour incident.
So how exactly does one line of code cost so much? Okay, let's dive into this because it's a perfect cautionary tale. A developer was building a new subscription API. During local testing, they temporarily added a flag that read debug_bypass equals true, which, as you can probably guess, basically granted enterprise-level access to literally any user account. They finished their work, self-merged their branch directly to the main production branch, and our automated systems went ahead and deployed it. For 4 hours and 12 minutes, free-tier users accessed tens of thousands of dollars of premium content. The developer completely bypassed the team's entire immune system. Just 4 lines of feedback in a proper code review would have caught this in 2 minutes, but the process completely failed.
Section 1. Defining the foundations. What is a branch?
Right, so to make sure a disaster like that never happens to us, we have to build a proper immune system. And that starts with stripping away some common misconceptions and understanding what a branch actually is at a fundamental level. A lot of people coming from older version control systems kind of think branching is this heavy operation, that it duplicates your entire codebase and eats up tons of disk space. Not in Git. A branch in Git is literally just a 41-byte text file that contains a commit hash. That's it. It is simply a pointer to a specific moment in your commit history. It's absolutely not a copy of your code. Because it's just this tiny text file, branching is completely free and practically instantaneous. This is a massive superpower for us. It means we can, and honestly should, branch aggressively without worrying about any performance penalty. Moving on to Section 2, the workflow showdown, Git flow versus trunk-based development. Now, what's really interesting about this next part is the great engineering debate. If you ever browse engineering forums, you'll inevitably see developers arguing passionately that one workflow is strictly better than the other. But the reality in the industry isn't about which is definitively best. It's entirely about which strategy fits your specific deployment situation, your product type, and your team size. Let's compare these two philosophies side by side. Over on the left, we've got Git flow. Git flow is highly structured. It uses 5 distinct branch types. You have main for production, develop for integration, feature branches for new work, release branches for prep, and hotfix branches for production emergencies. It heavily relies on merge commits to preserve a really clear historical topology of exactly what was built and when. Then, on the right side, we have trunk-based development. This basically inverts almost every assumption of Git flow. There is only one main branch, the trunk. Developers create very short-lived feature branches, usually lasting less than 2 days, and they integrate them into the trunk using squash merges. This keeps the history perfectly linear and clean, meaning code goes to main constantly. So you might be wondering, when do we use which? Let's walk through the specific use cases. Git flow really shines when your release quality gates are exceptionally high and your deployment frequency is low. For example, say you're building mobile apps that have to wait around for App Store reviews, or enterprise software that's subject to intense compliance audits, or maybe you support multiple major versions of a product out in the wild simultaneously. In those cases, Git flow provides a massive structured safety net. However, you definitely want to avoid it if your main goal is speed. If you're looking to deploy multiple times a day, and you already have mature continuous integration and continuous deployment pipelines, Git flow's branching overhead is just going to become a serious bottleneck for your team.
Now, if a team decides to avoid Git flow and chooses trunk-based development instead, they immediately face a glaring problem. How on earth do you constantly merge code to the main branch if the feature isn't even finished yet? Well, the answer is feature flags. Trunk-based development relies entirely on this concept. A feature flag is basically a system that allows unfinished code to sit safely in production behind a simple environment toggle. It elegantly decouples deployment from release. The code goes out to the servers constantly, but the feature itself only becomes visible to users intentionally, like when product managers actually decide to flip the switch.
Trunk-based development is basically the darling of modern software engineering right now. Dora Research, which by the way measures DevOps performance across the entire industry, proves that trunk-based development drives incredibly high performance, enabling teams to deploy thousands of times a day, just like Google or Netflix. You absolutely want to use it for SaaS models and microservices. But here is the critical warning. Trunk-based development absolutely requires automated tests and a highly mature CI/CD pipeline to actually be safe. If you have a very junior team without strict guardrails in place, no automated testing, or heavily regulated release cycles, trying to do trunk-based development can honestly be a recipe for total chaos.
Section 3. The Safety Net Professional Code Review.
Okay, whether you go with Gitflow's structured safety net or trunk-based development's continuous speed, the exact same principle dictates how your code ultimately lands in the main branch. Let's shift our mentorship focus from how we branch to how we actually merge. Opening a pull request and undergoing code review is the definitive process that separates senior-level engineering from amateur hour. Despite the somewhat confusing name, a pull request isn't really about pulling code at all. It is a formal proposal to merge your changes. It acts as our ultimate quality control mechanism. Every proper PR consists of 3 things: a diff viewer, so we can see exactly what changed, line by line, a discussion thread for async collaboration, and a merge gate, which are the automated and human checks that absolutely must pass before that code ever touches our main branch.
So the crucial point here is knowing exactly what we are looking for when we review a peer's pull request. We don't just skim it and blindly hit approve. We use a rigorous 5-part checklist. First up, correctness. Does this actually handle the edge cases? Second, security. Are there any hard-coded secrets or, say, debug bypass flags like the one that cost that company 51 grand? Third, tests. Are we actually testing the right behaviors? Fourth, readability. Could a brand new engineer understand this code 6 months from now? And finally, fifth, design. Does this fit cleanly into our existing architecture, or are we just introducing technical debt?
Section 4. Establishing team culture. Shipping with confidence. All right, we've covered the mechanics, the strategies, and the checklists. But let's be real, an engineering team is made of human beings, and individual discipline can be fragile. People get tired or they face strict deadlines. That is exactly why we use branch protection rules. These settings make our professional workflow mandatory. We literally disable the merge button until all our standards are met. We require at least 1 peer approval, no exceptions. We enforce that CI/CD status checks, like our security scans, pass green. We automatically assign reviewers using code owners files so the right experts always see the code. And critically, we completely block anyone from self-merging their own PRs. And this brilliantly illustrates the cultural core of everything we've talked about today. When you hit request changes on a PR, it is absolutely not a rejection of your teammates' work. It's a conversation. The entire goal is to improve the code before it ever reaches production. As professionals, we must frame every single comment as, "help me understand," or "have you considered," and never just, "this is wrong." The level of psychological safety we establish in our code reviews strictly determines whether junior engineers will learn and grow, or if they'll just become afraid and start hiding their work.
To wrap up this explainer, we've looked at the true nature of branches. We've debated the merits of Gitflow and trunk-based development, and we've outlined the completely non-negotiable standards of professional code review. The infrastructure is there, the checklists are ready, and the culture is completely ours to shape. So I'll leave you with this provocative thought. Are we ready to fully embrace these guardrails, adopt these standards, and build a world-class engineering culture that ships with total confidence? Or are we willing to skip a review, cut a corner, and risk writing our very own $51,400 postmortem? The choice of how we work starts with your very next commit.